All right, so now we're going to do some examples with the Riemann and trapezoidal sums. So the first thing that we're going to do is example 1. So it says, let's consider for a moment that the function f of x, which is negative 1/3 x squared plus 2x plus 5, it says this function is graphed below. So here's our function down here in the graph of f of x. It says on the interval 1 to 7, subdivide the area bounded by the graph of the function and the x-axis into rectangles of length of 2. Okay, place the upper left-hand vertex of the rectangle on the curve each time. Then calculate the area of each rectangle and sum the areas to approximate the area of the region under the curve bounded by f of x equals 1, and x is equal to 7. Okay, so let's put a line right here. This is going to be x equals 1, right? This is x equals 1, and that's like our, when we do our interval from a to b, so this is like where we're going to start at, so we'll put like a little a there. And then it's going to be bounded by x equals 7, so this would be my line here. This is going to be our b. So I'm finding the area under the curve between, and this is my curve, sorry, f of x. And we're going to do that dividing it up into rectangles. So it does say that we're going to divide it into rectangles of length of 2. All right, so that means that each rectangle, the base is going to be 2. So, you know, this right here is a width of 2. Then I'm going to do it again, right, with another width of 2 and then another width of 2. Okay, so that's what I'm doing. So what it says, in order to do this as a left Riemann sum, because it says that the upper left-hand vertex of the rectangle on the curve, so you're going to connect your rectangle so it has a base of 2 right here, and we're going to connect the left-hand side to my curve. So it's going to look like this. So I, put a little dot there. And then I'm going to draw a straight line across connecting the other side. So it's going to go here, and then it's going to go down there. All right, so that is, rectangle number 1. Kind of shade it in just a tad like that. Okay, that's the first one. So then my next one that I'm going to do, now I start here, right? And I'm going to go all the way up on the left-hand side until I hit the curve, which is going to be at this dot. And then I'm going to draw a straight line over and then come down and connect it. Okay, so now, this is rectangle number 2. And then my third one, again, I go all the way up this line until I hit the curve, which I'm going to hit it at about right here. And then I'm going to go and I'll go straight over and then come down like this, right? So this one is going to be connected like that. Kind of looks like that. Okay, so now I've made my rectangles, right? And so now I'm going to approximate the area of the region under the curve, right, using these rectangles or using what they call as a Riemann sum. So before I get started, I'm going to make a table. Okay, so I'm going to have x, and then down here is going to be f of x. So my x values are going to be, my x values where I hit the curve at. So I hit it here at 1. I'm going to do 1. And then I'm going to do it again. So I'm going to do it at 3. And then I'm hit it again here at 5. Right? And then I can hit it here again at 7. So we'll just go ahead and put 7. All right, so then f of x is going to be what my function is or what my y value is when I put in x equals 1. You know, so I could go ahead and just put it in here and evaluate it, or I can use my calculator to kind of give me some help. So I'm going to go here to my calculator, and I've already plugged it in, but at y, I'm going to go to y1, and then I just plugged in the equation, negative 1/3 x squared plus 2x plus 5. Okay, and then I'm just going to go ahead and I'm going to get the value. So, you know, just like we did before, I like to go ahead and change the table so that it is in ask mode. You don't necessarily have to, but I'm going to do it that way. And then I'm going to go here, and then I'm just going to find my value. So when it's a 1, you can see that it's 20/3. I'm going to go ahead and put that. When it's 3, it's 8. I don't have 5 listed on there, so I'm going to have to go ahead and find 5. So I put in 5. It's again 20/3. And then I have to put in 7. So 7 is going to give me 8/3. Okay, so now I have my table done. All right, so now what I'm going to do is I'm going to estimate the area. So I'm doing the area, right? And I want the area from 1 to 7 of the function f of x dx. Okay, so I'm going to use my left Riemann sum to do this. Okay, so remember that that means that I basically want the area of these 3 rectangles. Okay, so first thing that I have is my base. So my base has a width of 2. So I'm going to do 2. And then I do times f of x, and then I'm doing it on the left-hand side. So remember that like this hits it on the left-hand side of my rectangle. So I want to know what f of x is at 1, which is going to be the 20/3. So that is rectangle number 1. Then I'm going to do the base of rectangle number 2, which is 2. And then I'm going to do times what f of x is on the left-hand side of my rectangle, which is going to be at 3. So 3 is 8. And then I have to do my third rectangle down here has also a base of 2. I'm going to put 2. And then I'm going to put times what f of x is on the left-hand side. So that's where f of x is 5, right? So that's going to be 20. So this again, left-hand side of my rectangle. Okay, so then I'm going to just go through with my calculator, calculate what this is. So you know this is 40/3 plus 16 plus 40/3. I just add that together and I get 42.667. And we are going to round to 3 decimal places on these. Okay, round to 3 decimal places. All right, so that's what we're doing. So most of the time, you're not going to have to like take an equation. You're not going to have to like draw it. You just need to kind of visually understand what's happening. Most of the time with the Riemann sums, it's going to look like example number 2. Okay, but if you can like go back to this and understand, okay, well, that's what I'm actually doing, then maybe it'll make a little bit more sense. So basically what they've done is they have already given you a table of values for some continuous function f of x. Okay, so we don't know what the function is up above. They told us what the function is. And it says we're going to approximate the area under the curve from -2 to 10 of f of x dx with the following Riemann sum. So we're going to do one left and one right, one midpoint, and then also using a trapezoid just to kind of see the different ways to do it. All right, so the first way it says is we're going to use what is called a left endpoint Riemann sum, which is just like we did up in the example number 1. So we're going to do the area from -2 to 10 of f of x dx. So it does tell us that we're going to use 3 equal subintervals. So we talked about subintervals, right? And so we're going to divide this area up into 3 subintervals, okay? So our first interval is going to be from here to here. This would be, subinterval number 1. Then we're going to do it again. This would be subinterval number 2. And then this is going to be subinterval number 3. Okay, and you can kind of see that they are going to be equal, right? We're going from -2 to 0, 0 to 2. I'm going up by increments of 2 each time. Okay, so this is going to be my base, right? My distance from -2 to +2, that's my base. And so each one of them is going to have a base of 4, right? I'm having a distance of 4 in between them. So my first rectangle is going to have a base of 4. So I put 4. And then it's times f of x on the left-hand side of my rectangle. So the left-hand side of my rectangle, it's going to connect at -2. So that means that this is going to be my first value, my f 4.8. So I'm going to put 4.8. Okay, so that's rectangle number 1, right? So then I have to add in rectangle number 2. So rectangle number 2 is going to go from 2 to 6 right here. So it still has a base of 4, okay? And then I have to multiply it by the height, or what f of x is on the left-hand side of that rectangle. So it's going to be right here, right? So the value is going to be 2.1. Then I do it again. Now I have rectangles, so this was rectangle 2. And then I now have rectangle 3. Okay, so rectangle 3 goes from 6 to 10. And then, so it has a distance also of 4. And then it's going to be the f of x value on the left-hand side of the rectangle, which is going to be the 1.5. So then I just use my calculator and I go ahead and, multiply 4 times 4.8, 4 times 2.1, 4 times 1.5. And I'm going to do that right now. And I end up with 33.6 as my answer. Okay, so let's keep going. Part B. So part B, we're going to do a right Riemann sum. Okay, so right Riemann sum, still the same notation, -2 to 10, f of x dx. So I am still using 3 subintervals. My intervals are going to be equal. And so my rectangle is still going to be a width or a base of 4. So I'm going to do 4. But this time I'm going to connect to f of x on the right-hand side of my rectangle. Okay, so that means that I'm going to use this value right here to start with. I'm going to start with 2.1 because I'm now starting with the right-hand part. So I'm going to do 2.1. Okay, then I look at rectangle number 2. So here's rectangle number 2. Still has a width of 4. But it's going to connect on the right-hand side. So that means that it's right here. So it's going to be 1.5. And then now I have, so this is rectangle 1, sorry, this is rectangle 2, and now I have rectangle 3. So rectangle 3 is going to also have a base or a width of 4. And then I'm going to connect on the right-hand side of this rectangle where it hits f of x, which is now going to be 2. All right, so once again, I'm just going to plug this into my calculator. 4 times 2.1, 4 times 1.1, 1.5, and then 4 times 2, add them together, and I get 22.4. All right, so next one is what they call a midpoint Riemann sum. Okay, so I'm going to go again. I'm going from negative 2 to 10 of f of x dx. So still using 3 equal subintervals, so that part of it isn't changing, right? I still have a width of 4. So rectangle 1 has a width of 4, but then I have to see, okay, well, where is the midpoint of that? And you'll notice like this middle right here would be the midpoint, 0, okay? And so the f of x at the midpoint would be 5.7, like that. Okay, so then I would go to, this is rectangle number 1. Then I would go to rectangle number 2. So rectangle number 2 again still has a base of 4, or a width of 4. And then it's going to connect at its midpoint. So the midpoint is going to be this, which is 1.3. And then I go to, so this is rectangle number 2. And then I go to the last one, which is rectangle number 3. It also has a base of 4. And then it connects at the midpoint, which is negative 0.7. So this would be rectangle number 3. So then I just load that into my calculator, add them up, and it's going to be 25.2. All right, so then the last one on this is a trapezoid. So trapezoid, we're going to do from negative 2 to 10, and we're going to do f of x dx. So just on a side note, I'm going to kind of write to the side. Remember that the trapezoid formula is going to be height, right? And then base 1 plus base 2 all over 2. Okay, so that's the area of our trapezoid. So we're going to, again, use 3 subintervals. So that part of it hasn't changed through this whole thing. So when you look at this, right, your height is going to be the distance between your trapezoids, or between your 2 bases. So this is going to be 4, and then I'm going to have base 1, so it's where I hit the f of x on the left side, and then where I hit it on the right side. So I'm going to connect it at here, which is 4.8. Then I'm going to connect it on the other side, which is 2.1. And then I'm going to divide that all by 2. So that is trapezoid number 1. Okay, so then I have to do trapezoid number 2. So trapezoid number 2 has a height of 4. It's going to connect on the left-hand side at 2.1. And then on the right-hand side at 1.5. And then I'm going to divide it by 2. So this is trapezoid number 2. Then I have trapezoid number 3. Again, base of 4. Left-hand side is 1.5. Right-hand side is 2. And divided by 2. So you can kind of clean this up, right? You can see that, they all divide by 2. So I could go ahead and I could do this 2 times, and then 4.8 plus 2.1, 6.9, 2 times, this is going to be 3.6, 2 times, and that's going to be 3.5. And then you can just go ahead again, put this in the calculator. 2 times 6.9, 2 times 3.6, 2 times 3.5. And you end up with 28 as your answer. All right, so now we're on to example 3. So it says the data in the table represents the rate at which rain fell over the course of 12 months. Using the subintervals given in the table, use the given Riemann sums to approximate the area under the curve, or the integral from 0 to 12 of RT dt, the total amount of rainfall over the year. All right, so it says that we are going to use the sub-intervals given in the table. Okay, so that means that, each one is going to go like this, right? This is the first subinterval, then we have the second subinterval, then the third one, then the fourth one, the fifth one, and the sixth one, and so forth. Okay, so some of them might be different widths. So this is a little bit different than the one that we did last time. Okay, so it says we're going to use a left Riemann sum. Okay, so we're going to start. So we're going to do from 0 to 12, and we have R, T, dt. So we're going to start with our rectangles, right, because we're doing a left endpoint Riemann sum. So we're going to look at our first rectangle, goes from 0 to 2. So it has a base of 2. And then we're going to connect it to f of x on the left-hand side. So that means, this is my left point. So it's going to be 9.4. All right, so then I keep going. So the base here from 2 to 3 is only 1. On the left-hand side, it connects, so it would be 12.3. Okay, so then I move to rectangle 3. So this is going to have a width of 2, right? Connecting on the left-hand side. So this was left, this is left. So 15.7. Okay, then I keep going. So now I'm at between 5 and 8. So 5 and 8 is 3. Connecting on the left-hand side is 13.3. Now I'm going from 8 to 10, which is 2. And then on the left-hand side of that rectangle is 12.6. And then lastly, this last rectangle, 10 to 12, is a 2. And then on the left-hand side is going to be 8.4. All right, so then I just go ahead and I, put all that in the calculator, multiply it, and then add it together. And I end up with 144.9 as my answer. Okay, so now we're going to go down and do a right endpoint Riemann sum. Okay, so I'm going from 0 to 12, again, RT dt. And so now I'm going to, look at my rectangle, but now I'm connecting it on the right-hand side. So rectangle number 1 has a width of 2, but now the right-hand side is over here, right? So this is going to be 12.3. Then I do my next one, which has a width of 1. Connecting it on the right-hand side now is 15.7. Then I have my next one, which is going to have a width of 2. Connecting it on the right-hand side is going to be 13.3. Then I have my next one, which is going to have a width of 3. Connecting it on the right-hand side is going to be 12.6. And then I have my next one, which has a width of 2. Connecting it on the right-hand side is going to be 8.4. And then the last one is 2. And then I'm going to connect it on the right-hand side. And then, so it's going to be 9.7. All right, so again, putting it in the calculator, I'm going to multiply it all together, add it together, and I'm going to end up with 140.9 as my area. Okay. All right, so last one is the trapezoid. Okay, so, once again, with the trapezoid formula, and I'm just going to write it up here. Trapezoid formula is going to be our height, base 1 plus base 2 divided by 2, like that. Okay, so I'm going to go through and find each one of the areas for each one of the trapezoids. So I have the area from 0 to 12 of RT dt. Okay, so first trapezoid is going to have a height of 2. Base 1 is 9.4 plus 12.3, all divided by 2. Then I have trapezoid 2, which has a height of 1, and I have 12.3 plus 15.7 all over 2. Trapezoid number 3 has a height of 2, and it has a base of 15.7 plus 13.3 all over 2. Then I have my next one, which is going to have a height of 3, and that's going to be 13.3 plus 12.8 all over 2. All right, then I have to keep writing underneath it. Okay, so then my next one has a height of 2, and that's going to be 12 point, I wrote 12.8 by accident, 12.6. All right, so 12.6 plus 8.4 all over 2. And then I have 2 times, and then I have 8.4 plus 9.7 all over 2. All right. So, you can kind of go through and clean up some of this prior to putting it in the calculator, right? Like you can see that this right here is going to cancel out, right? This is going to be 1/2. These 2's are going to cancel out. That's going to be 3/2. These 2's are going to cancel out, kind of like that. So, before you go through and like stick the whole thing in the calculator, you could have, 9.4 plus 12.3, and then you're going to have plus 1/2, 12.3 plus 15.7 plus 15.7 plus 13.3 plus 3/2, 13.3 plus 12.6, and then plus 12.6 plus 8.4 plus 8.4 plus 9.7. So you could kind of go through and do that just to kind of clean it up. Honestly, it's not going to matter. You're just going to load it all into the calculator. All right, so you load it all into the calculator, and your answer should be this. It should be 142.6. All right, so last example is number 4. Okay, so number 4 says, you have a chart which is T hours. This is H prime of T, which is in feet per hour. It says the height of water in a storage tank during a 15-hour period is given by a twice differentiable function H, where H of T is measured in feet and T is measured in hours since midnight from 0 to 15. The graph of H is concave up on the interval 0 to 15. And it says selected values of the derivative H prime are given in the table above. At time t equals 2, the height of the water is 7 feet. Okay, so first of all, it wants you to find the area under the curve of H prime of t, and it says that you are going to use a right Riemann sum, and it says 5 subintervals, right, indicated by the table in the data. So if I do 5 subintervals, it's going to be 1, 2, 3, 4, 5, right? So I'm just going to use the subintervals that are given in my table. Okay, so I'm going to go from 2 to 14, and I'm finding H prime of t dt. So on the first one, right, it's going to have an area of 2, or a base of 2, sorry. And then I'm on the right-hand side, so I'm multiplying by 0.6. Then I'm going to have a base of 1 for the next one. The right-hand side is going to be 0.7. My next one is going to be 3. Right-hand side is 1.4. Next one, I'm going to have a base of 2. Right-hand side is 2.3. And then I'm going to have a base of 4. Right-hand side is 7.7. All right, so then I just put it in the calculator, and it's going to give me 48.5. Okay, so the next part says, is the approximation in part A an overestimate or an underestimate for the area under the curve from 2 to 14 of h prime of t dt, and indicate your units of measure, right? Okay, so first of all, we have to look at this function, right? Because if we went back and we looked at our notes as to figure out if it's an overestimate or an underestimate, you have to know, first of all, if it's increasing or decreasing, and then you have to decide if it's a left-hand Riemann sum or a right Riemann sum, okay? And on part A, we did a right Riemann sum. Okay, so if we notice that t is going from 2 to 14, right? And this is going from 0.3 all the way to 7.7. So we know, if I drew my little picture, I could go back and I can remember, but sometimes it just helps you if you can think in terms of a picture. So I have an increasing function that looks like this, okay, and I'm connecting to the function on the right-hand side of the rectangle. So I would divide this up. It would have a rectangle on the right-hand side, and I draw it this direction. So I connect here, go over, down, here, over, down, here, over, down. So when I look at it, I can see that I have all this space that is outside of the area under the curve. Okay, so what does that mean? That means that I am overestimating this thing, okay? So by using a right Riemann sum on an increasing function, I am going to overestimate the area under the curve. Okay, so what am I going to write? I'm going to say the approximation in part A is an overestimate because, remember that we always have to justify why. So why? Because h prime of t is an increasing function and we used a right Riemann sum to approximate. Okay, so it's an overestimation. Why? Because one, it's increasing, and two, we used a right Riemann sum. All right, and so if I'm going to estimate, or if I'm going to do the area, and I want to do my units of measure, then my units are in feet squared per hour. Because remember, we're talking about area, so we're going to have to put it in feet squared. All right, so the rest of this worksheet is for you to do. I will have the key posted on Canvas after the first day, or after today, so that you can go back and you can check your answers and see if you can get them correctly. If you have any questions, just email me.